We're discussing the various ways of expressing concentration, and in this video we'll be talking about mass by volume percent or percentage and parts per million. Now, mass by volume percentage is basically the mass of the solute in 100 ml of the solution. Now, that's again too vague. So let's say we have 10%. This is the example given in your textbooks. So W by V NaCl solution. So what is the information that we get from this? This tells us that 10 grams of NaCl has been dissolved in 100 ml of water. So the mass by volume percent is mass of the solute that is dissolved in 100 ml of the solution. So 10% of NaCl would be 10 grams of NaCl dissolved in 100 ml of water. The last one for this video is parts per million. Now, parts per million can be expressed as a mass to mass. It can be mass to mass, and or it could be mass, or let's say volume to volume, or it can also be mass to volume. Let's take an example of a solution where the solute or the component for example, we have a solution which contains two components, the solute and the solvent, and it's a particular volume of that particular solute, and that volume is very, very, very low. Okay, so low that you can't even detect it. And we need super sensitive equipment to detect it, and it does detect it, obviously, but the thing is, when you express it and you have so many decimal points, it gets really, really annoying. And because of that, we have something called as parts per million. So parts per million basically means that the part of the component which is in million parts of the solution. And in a solution, let's say, for example, we have two components, A and B again. So the parts per million of A will be equal to the mass of A divided by mass total mass into 10 to the power 6. So in 10 to the power 6, that quantity of the solution, how much is the mass of A is given by parts per million of A. So that ratio is given as parts per million because it gets really difficult. So in your textbook, you've been given an example of 1 liter of seawater. So here we have a mixture of oxygen and seawater, and we're talking specifically about oxygen in that mixture. So the mass of oxygen in that particular mixture equals to 6 into 10 to the power minus 3 grams. Okay, the next one is mass. So the one mass of 1 liter of seawater equals to 1030 grams. So the parts per million of oxygen will be equal to the mass of oxygen, that is 6 into 10 to the power minus 3 divided by 1030 grams, and this is also in grams, this and this gets cancelled, and into 10 to the power 6, and this equals to 5.8 ppm. So this means that in 1 liter of seawater, 5.8 parts per million of oxygen is present. And That's it. So usually we use parts per million, especially when we talk about the various impurities and like the pollutants and all of that. We talk about it in terms of parts per million. And there is a particular amount beyond which we prefer the pollutants not to exist. And um, it's also it can also be represented as micrograms per ml or parts per million for these pollutants. With that, we're done with the fourth way of expressing concentration. In the next video, we'll be talking about mole fraction.